Well, good morning, Gil. It's very good to have the opportunity to be with you today, and really kind of looking forward to learning about you and about the Veterans Administration's efforts in artificial intelligence. So thanks for being with us.
Great, and thanks for having me on the ATARC Federal IT Newscast. I really appreciate the opportunity to talk to you today.
Well, thanks. So Gil, getting right into it, give us a little bit of background about yourself, where you're from, how you got here, and what drives you in the Veterans Administration and in your pursuit of artificial intelligence as applied to the VA's mission.
Yes, so I think, when thinking about the drive and what are some of the things that really are motivating to me and to us really here at the National Artificial Intelligence Institute, we're thinking about the veterans, the mission of the VA, and how we can best help the veterans, their families, those around them. When looking at that, it turns out that there's a number of new technologies, and one of them, artificial intelligence, really stands out as something that can really make a big difference from what we've seen in its application in other areas, other industries and in academia. I know in terms of my background, in the past, I'd worked on applying artificial intelligence in healthcare and seeing how that can really make a difference for patients. And so have been really excited that we have this opportunity for this really special mission that the VA has to really make a difference.
Okay. So you said there was something particular, an advancement recently that was very intriguing to you. Can you give us a little more detail?
Yeah, well, I think when we think about artificial intelligence, it's been kind of a journey essentially through time, right? It's not something that I think you kind of almost think about almost like life itself, right? It's not that you reached a certain goal necessarily at some point and that's it, but you kind of evolve, from being a child to an adult, an older person, and so forth. And in each time, there's sort of different things that come about that can give you new insights, new capabilities. I think that's how it is with artificial intelligence. It's there are certain moments when you sort of have this aha that kind of come up, but I think that overall, it's kind of a cumulative effect of things. So for example, in the last few years, imaging, we've seen artificial intelligence being able to have essentially superhuman capabilities in recognizing, classifying images, and understanding what they mean. And so that has a lot of applications in the healthcare area, whether you're looking at diagnosing cancer images, looking at prognosis, how well a patient will do over time given a certain treatment, where you're using imaging to understand what that situation is. Same thing with text processing. Have seen some amazing capabilities in that area as well. Starting to get toward the point where it is hard to tell the difference from a human and an artificial intelligence kind of a chat kind of session there. And so that allows for a number of interactions that before may not have been possible. And so all of these are being driven by different technologies over time and different resource capabilities that are being made available over time. So sometimes there's a dramatic increase in like a new method, whether it be like, for example, deep learning, neural networks, a few decades ago that were kind of a little more simpler version of the deep learning that we have today. And then by resources, whether it be the computing resources that are getting faster over time, having more memory, and the data itself. The data itself is really critical. And there's some situations where just having a lot of data can actually lead to great results in terms of being able to make predictions. There are other cases where you need not only data, but some of the newer methods as well. And so there's a lot of different variables to think about. But I think the one that we're thinking about now is this, about AI adoption, right? That's kind of what we've been thinking about. So, and the road to AI adoption really goes through these waypoints, as I mentioned, kind of like a journey, right? And trustworthy AI is really an important part of the journey that we're at now. And to get adoption, it needs to be trusted, right? Once you get that, you open that gate. There are a lot more capabilities because you're able to adopt AI, try it in different settings, and ultimately be able to standardize and develop processes where you're looking at, increasing the accuracy. So right now, I think getting AI to make sure that it's following the different trustworthy principles. We've got these 9 principles that we worked on as part of the that we have as part of the trustworthy AI executive order that's also encoded in the National AI Initiative Act that came out. And that's kind of an important one to really make sure that we have that to increase adoption. After that, we're of course looking to make sure that we've got high accuracy, right? That's important, and that it is better than the alternative, right? There's no really reason to implement something if it's not better than how things are being done now, unless it's better in some metric. That metric could be accuracy, it could be cost savings, it could be ideally it's a combination of different factors. So those are the things being looked at now.
So in specifics, how is artificial intelligence being deployed at the Veterans Administration? What kind of problems are you seeking to address? What is the primary foci of your efforts currently?
Right. So there's a number of things that we're looking at. I think I kind of alluded to a couple of them. There have been a number of efforts looking into how do you use it for imaging. We, in terms of overall use cases, we recently actually created a use case library that we will soon publish. There is an initial list already on the website, basically www.va.gov/guidance, where we talk about how we're using it we're looking at some of the priority use cases there. But, if you put them into categories, there are kind of these clinical use cases. There are these administrative use cases. So administrative, I talked a little bit about the clinical before, but administrative may be, for example, to make certain forms processing faster using natural language processing, having ways to submit forms in more automated ways, recognizing images and handwriting, so that way it doesn't have to be manual typed in, having artificial intelligence process certain types of information and integrate different types of information together that can help to help increase productivity, essentially. So that's kind of the other area. And that may include areas that intersect with the clinical or the benefits or the cemetery administration. There are different parts of the VA that it can contribute to. I think the key is that looking at where is the data that we could really leverage, right? The VA has a lot of information that can be useful for its mission. The largest integrated healthcare system in the country, over 9 million veterans there, being served with, healthcare areas, benefits, and memorial services, different types of places where there are interactions with a veteran, where leveraging the data that is underlying that can help make for better experiences, can make for results that are faster, and kind of improve the outcomes that we see for the veterans and those around them.
Excellent. So, are there specific processes to the development of artificial intelligence algorithms or implementations at the VA? Is this happening exclusively in-house? Is there a public-private partnerships or cross-agency partnerships?
Right. Yeah, there's a lot of different ways that we're working on this. So I would say it's a combination of those, right? Each one has its strengths, its strengths, its pluses, its minuses. For example, we're looking, we've been looking at just give an example of partnerships, potential partnerships. So one of the challenges there in the past has been around contracting. How do you make that faster and more efficient? We've been looking at and using things like AI tech sprints, which allow us to engage with industry over a period of time, like 3 months or so. And during that time, we can work on shared data sets where they're working on different tools that may be of interest to areas that are being worked on there. And once they have something, they can show it and compete in different challenges that we have. So we had one recently. We worked with challenge.gov. And as part of that, announced recently some prizes for that. And that's been a way that we can have a national competition that can then drive potentially future contracts, because that is a way that because in contracts, you need to have a justification for having the contract essentially through some kind of a process that is fair and equitable. In the challenge.gov and other types of ways that we work with AI Tech Sprint enable us to then be able to move a little more faster toward contracts that are going to be beneficial for all sides and for the mission itself. So that was around partnerships. There are also these cooperative research and development agreements. We had a number of these recently that led to a number of different research and development projects that are now bringing different models and so forth that will be useful as well. And in the health related arena, we also try to bring either both researchers, clinicians, and others to develop their expertise in-house. We have a program that we're working on to be able to increase capabilities in that area through funding and training. And then there's also areas that we're working on to bring people from the outside into government. So building this AI network of people from outside the VA to bring them to within the VA, people that have this expertise or have both in AI and applying it to specific use cases. So we're looking at a multiple of different areas, kind of a multi-pronged approach, and each one has its advantages, like I was alluding to a couple of them, and disadvantages. So together we're able to take advantages of all the different pluses that each one of these opportunities affords us.
That's really exciting. It's very refreshing to see such a broad, fully scoped approach to leveraging internal and external expertise. I imagine that the response has been pretty significant, significantly positive, given, as you pointed out, the VA has vast holdings of data, very diverse data sets, and very diverse missions. Everything from healthcare to benefits to administration to even funeral services. It's and the age of that data, the longevity of that data is also really attractive. So not only do you have a large body, a large corpus of current data, but an opportunity to examine how elements of that data have evolved over a span of decades, which can be extremely useful. I think a lot of times people think that an AI algorithm is born and suddenly it knows everything, but the truth is that it is very often going to have to go through the same cognitive processes as any infant that transitions through maturation to being a functioning, thinking, aware entity. So essentially, the more data you have, the more homework you're giving your AI to learn and improve upon. And when you have that, it allows you to develop a more robust algorithm that's well suited to its purpose. Researchers that I've had the opportunity to work with at a number of companies always say that more data is better. The key to success for a lot of companies that have been able to successfully leverage AI is that they have vast quantities of data to train against. And Google is probably one of the most noteworthy, but certainly that's the scale of data we're talking about. It's petabytes, it's exabytes of data that can be processed. So that brings in challenges in infrastructure as well. It's very, very difficult to work with huge quantities of data just from the data gravity and the data velocity problems. When you have tens of thousands of instances of an algorithm trying to train against massive diverse data sets, just the bandwidth alone becomes a huge challenge. And there are very few organizations that have that kind of infrastructure available to them. So the benefit to government is very often the infrastructure is large, but there's also the opportunity to leverage other infrastructure. So it sort of begs the question of, what model of infrastructure are you using at the VA? Is it predominantly on premises, or is it hybrid, or is it entirely in the public cloud, or is it combinations of all of the above? How are you finding it most effective to do the data triage and cleanup, the training, and then ultimately deploying into the mission environment or the application environment for that particular algorithm or use case?
Right. So there are a number. So like the approaches that we've been using for working on with AI, working on partnerships and so forth and all that. The same kind of thing we're doing also around the infrastructure, right? So for example, there's the VA Data Commons piloting work that's going on, which involves working with a portion outside of the VA, essentially as a cloud-based environment, right? And then there's approaches where we're leveraging GovCloud within the VA to work with people, within the VA. There are other environments that are kind of smaller on-prem based environments as well for specialized data, like genomic data analysis that are available for doing analysis. And so there's a combination. I want to get to the point, that you were asking or that you were discussing before. I thought it was quite interesting about, when you have a lot of data and it's longitudinal, you also want to think about, that affects also the infrastructure and so forth that you'll be using as well. And it's interesting, you get 1 billion new images a year. Those are stored somewhere. How do you, when you have developed AI models, how do you kind of integrate all those images? Just imagine how many images are coming in, every day. You've got 1 billion new ones every year, right? How do you make sure that you can, plan for such a future where that can be done? And it's not only that there's a lot of data there right now, but there's a lot of data coming in. And so the models may learn something, that is relevant now, and that actually may change, in just a little bit of time. If you're looking at, intensive care unit data, as you get more data, your predictions may change, right? We've seen this actually with COVID-19. We had developed a model using some data, from some of the first waves. Then, there are different treatments, there are different types of variants, different things that came out, and the model, essentially, the model performs much better if it learns, adapts to those things that happened over time, right? And so I think one of the great capabilities and unique aspects is not only having a lot of information, but having access to, either real-time or near real-time information so that those models can be updated and you can provide the latest and essentially greatest types of models to understand what are the different variables, right? And you look at like explainable AI and be able to see and work with people to understand, oh, well, this is what changed in the model over time, and this is potentially why that is, and could that be something that would affect how we think about care or attacking different types of problems. So it's quite interesting to be able to have that aspect as well, where you keep learning from the data sets that are changing quite rapidly over time, right? Unlike some, data sets that don't really change, these are data sets that evolve and are changing based on different circumstances.
There's certainly the aspect of data changes because the things we can know evolve over time as well. 60 years ago, 70 years ago, if you'd asked somebody to describe DNA, there was no means by which to validate it. We couldn't see it. Now we've mapped the human genome and we know that exquisitely. So that will change a model. It changes our cognitive understanding of our subject area or of the universe. The same thing happens with artificial intelligence as well. What can be known and processed becomes apparent to us, and that's going to have an impact on what we want an algorithm to adapt to, or what an algorithm will decide to adapt to. Yeah, digital imagery was not widespread 20 years ago, 30 years ago. Now it is.
Yes, I think actually, yeah. Oh, go ahead.
No, go ahead.
I was going to say, I think what's interesting is that now, I think in the past, it was kind of like a one-way conversation, it's like, and that's been changing. So like in the past, it'd be like, we're teaching AI, right? And AI then comes up, and maybe makes a summary, and many times we didn't actually learn something new, but what it did was it kind of created a summary or put together information that it would require many people to look at that information over a long period of time, and it just made it faster or more efficient. But, if you look at some of the results in the last couple of years, where artificial intelligence is having superhuman capabilities in some areas, like in some areas of imaging, we're actually learning new things from artificial intelligence itself that none of us knew. Like you could have asked anyone and they would not, it's not a matter of like, we didn't read enough information. It's able to, there were findings around the types of cells that were in the periphery and the inside of cancer tumors that were essentially discovered by artificial intelligence. We're seeing patents being given to, or discussions about patents in different countries should it be given to artificial intelligence for making that discovery. So we're really in a new era where it brings a number of questions that we want to think, we're thinking about, whether it be around trustworthy AI and other things that once we're dealing, they're being dealt with right now, in terms of some of these things that I mentioned. And so it's really an exciting time, I think, because we're learning new things. And I see the future as a potentially more collaborative, kind of a human and computer interaction, where it may be more like a conversation. Not like us telling the AI do this and then it does something, but we may tell and say, how about trying this out? Look at this. It may say, oh, okay, that's interesting. Can you tell me more about this other aspect? And maybe then I'll investigate more. Kind of like how you might work with a colleague, right? When you work with a colleague, one of the most important things is that you trust them, right? And so that's kind of one of the things that kind of is being worked on. And once you have that, you can have conversations and be able to trust what they are reporting. I would say right now we'd want to verify, of course, everything. And it's a time we're in this special time. And of course, having the human kind of in the loop is always going to be important for most of these areas. But it's a unique time, I think, that to look at the possibilities that these capabilities are going to enable us to have.
So we are indeed in interesting and exciting times. And there have been tremendous advancements in artificial intelligence and augmentation of human cognition. But what do you see some of the current challenges in this area are, and how are you seeking to address them? How are you going forward from here?
Right. So I think there are kind of specifically AI challenges. There's specifically challenges around AI in health, and places where you have kind of personal identifiable kind of information, not always in health. It could be other areas, financial, other areas as well, administrative data. And then there's sort of general data challenges, right? So, when you look at data, just, sharing data is kind of an area that is a challenge sometimes. It could be a challenge to share data outside the agency for certain purposes, between agencies, within different agencies, just that idea of sharing data as seamlessly as possible, while, of course, the most important thing being able to maintain the privacy and to ensure the security of the resources there, so that we're doing the right thing in terms of protecting that information. That's a kind of a challenge there. And it's important for artificial intelligence because all those models are really built on that data. Those models essentially encode that data in a certain way. And so being able to make sure to protect that data is really, really important. Now, when you get into the health, certain financial administrative areas, you have identifiable information potentially. And so there are challenges in like methods of how you de-identified in such a way that it cannot be re-identified. And so those are some challenges in terms of like finding methods to do that, or building new approaches like privacy preserving AI, which essentially allow you to work with the data without having to see the underlying data itself. Like the model does not see directly the underlying data the way it's encrypted. And so there are ways that are being looked at to address that challenge as well. And then, as I mentioned, there are kind of some specific things to artificial intelligence that are challenges. So I think best way to give this is to potentially like an example. So there are, right now, as of, really just a couple of years ago, there are ways where artificial intelligence can have a voice that sounds so real that to many people, they won't be able to most people, they won't be able to really know if it's a human that is calling them on the phone or an AI agent, essentially, right? And so this has been implemented in some settings, like where not at the VA or within government, but it's from what I understand, it's been implemented in some industry settings, and in other cases as well, where the AI agent is making phone calls to people, right, to accomplish a task and make it more essentially optimal in terms of saving time and cost savings and things like that. And the person on the other side may not know that it's not a human. Is that there are questions about that people are raising. Should that be something where it's identified? Should it be transparent and that human informed that on the other side of the phone it is a AI agent and not a human? You might think, well, maybe if you are getting what's kind of sometimes called a robocall or something, you might deal with it differently than if you think it's a human, where you might give it more time and not want to kind of hang up quickly, or or interact with it in a way that depending on not affecting the feelings of the person, rather than the feelings of potential feelings of the AI agent. And so there are different ways that people may interact with a person rather than a robocall. This is just an example of the kinds of things that we're seeing that AI can do, and that we want to think about and challenges in terms of how do we want to deal with that before potentially implementing something like that. And that was one example. There are many things people talk about, or people have seen with deep fakes and others. You're making a movie that represents a person, how to deal with that, working with that person to ensure that would they want to do that or not, and how to represent different concepts. Those are all the kinds of things that are unique to AI, not to the underlying necessarily data, but to sort of that AI human kind of interface and understanding of how kind of humanity is going to deal with artificial intelligence. These are all challenges that are being looked into. We're right now kind of at that interface, at that pioneering moment when these things are starting to come out as options that need to be examined, whereas a few years ago they just weren't there. If someone is making a call, you can easily have recognized that it's not a human, for example, or if you see a movie clip, you could have obviously told that it was someone kind of stitched something together.
Mm-hmm. Well, Gil, I want to thank you very much for your time, your insights, and the enthusiasm that you bring to the topic area. And thank you very much for your efforts in coming from academia into the public sector, to the Veterans Administration, to help guide and spearhead the AI efforts of the Veterans Administration and coordinating that across other government agencies as well. You've had a very long and illustrious career in academia and in this field of research, and I think we're very fortunate to have you. If you have anything that you want to provide in parting comments, we're surely very eager to hear them.
Well, Nick, I just want to say it's been a pleasure to be here. Thank you very much to you, to the ATARC Federal IT Newscast, for starting this series. Really excited to see kind of the next ones that are coming up, and I think it's really was really a great idea to kind of have these where you kind of focus one-on-one and get to know different people, and really excited about the future in this field overall. Because it can really make a big difference for the mission that we're looking at. It's I know it can be useful for other missions as well. We've been interacting with a number of different agencies and with industry, with others in this area. And some of the things that when you see them coming out, it takes 2-3 more years to develop it. And so right now we're seeing things develop that are just really fascinating. I'm just looking forward and really excited to see the day when these technologies are going to make a difference directly to the people that we're working to serve. So thank you very much again, and great to be here.
Thank you, Gil. And once again, thank you all for joining us on the ATARC Federal IT Newscast. And our thanks to Kirsten Patton for putting all of this together. You have a wonderful day, and we'll see you again soon.